Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled The Attention Mechanism. AI's Selective Focus Superpower, how AI learns to pay attention to the most important parts of data. Imagine you're a student trying to study for a huge exam. You have tons of textbooks, notes, and online articles. If you try to read everything from start to finish for every single question, you'd be completely overwhelmed and likely miss the truly important bits. Developer perspective. Traditional AI models, especially before attention, faced a similar issue with large inputs like long sentences, complex code, or big images. They had to process information sequentially, often forgetting earlier parts by the time they reached the end, or struggling to see connections across distant parts of the data. This limited their ability to truly understand context. Just like a smart student learns to scan the material, highlight key sentences, and focus on relevant sections for each question, attention gives AI models this selective focus. It's like giving your AI a superpower to intelligently decide what's the most important piece of information here, right now, for what I'm trying to do. Single quote. Developer perspective. Attention is a mechanism that allows an AI model to dynamically weigh the importance of different parts of its input data when processing any single part of that data. Instead of treating all input equally, it assigns varying attention scores, or weights, to different pieces, effectively highlighting the most relevant information. Think of searching for a specific book in a library. Query. This is your current question or what you're looking for. E.g., where are the AI books? Single quote. Keys. These are the labels or descriptions on all the shelves in books. E.g., fiction, science, history, AI, cooking, values. These are the actual books or content stored on those shelves. Developer perspective. In AI, when the model is processing a specific piece of data, the query, it compares it to all other pieces of data, the keys, to figure out which ones are most relevant. Based on this comparison, it then intelligently selects and combines information from the relevant values to inform its next step. This comparison is often done using clever mathematical operations. Back to our library example. When you compare your AI book's query to a history key, the match is low. Compared to an AI key, the match is high. Attention does this comparison mathematically, creating similarity scores, or attention weights. A high score means pay lots of attention here. A low score means this is less important. Developer perspective. For each query, e.g., a word in a sentence, the model calculates a similarity score against every key, e.g., every other word in the sentence. These scores are then often put through a softmax function, a common neural network trick, to turn them into probabilities that sum to 1, effectively saying, distribute your 100% attention among these parts like this. These weighted values are then combined to form a richer, context-aware representation for the query. Imagine translating "the cat sat on the mat" when generating the French word for cat. A model without attention might just look at the and cat. But a smart human translator knows that sat and mat are also very relevant to understanding the full context of cat. Attention lets the AI look at all words in the English sentence when deciding how to translate each word into French. Developer perspective. For an AI translating an English sentence into French, when it's generating the French word for cat, the attention mechanism allows it to simultaneously look back at the cat sat on the mat in the English sentence. It assigns higher attention weights to words like cat and sat to produce a more accurate translation, understanding the crucial relationship between these words. Attention isn't just for text. Think of a doctor examining an X-ray. They don't look at every single pixel equally. They focus on specific areas that might show a fracture or abnormality. Attention lets AI do this for images too, highlighting important regions. Similarly, in audio, it can focus on specific instruments, voices, or crucial sound events. Developer perspective. For images, an image can be broken down into smaller patches, like little squares. Attention can then be applied to these patches, allowing the AI to focus on the most relevant visual information, e.g., the eyes and nose when trying to identify a face, rather than processing every single pixel equally. This makes image analysis much more efficient and accurate. So, what does this superpower achieve for AI? 1. Better understanding. AI grasps context much better, even in long, complex data like entire articles or long stretches of code. 2. Handles long data. No more forgetting the beginning of a long sentence, document, or image sequence. 3. Explainability. A little. By visualizing the attention weights, developers can sometimes see which parts of the input the AI focused on, offering clues as to why it made a particular decision. Developer perspective. Attention significantly improved model performance. Especially with sequential data, it allowed for the creation of much larger and more powerful models that could process unprecedented amounts of information. It also laid the groundwork for the transformer architecture, which is the backbone of almost all modern large language models, LLMs, like ChatGPT. Attention was such a game changer that it led to a whole new, powerful way of building AI models called transformers. These architectures, entirely built around the attention mechanism, are what power most of the impressive AI tools you see today. From advanced language models that write essays to cutting-edge image generation systems. Developer perspective. Before attention and transformers, many models processed data sequentially, which was slow and struggled with long-range dependencies. Transformers. By using self-attention, where a word pays attention to itself and all other words in the same sentence simultaneously. Process data in parallel. This makes them incredibly efficient and scalable, fundamentally changing the AI landscape and opening doors to AI capabilities we once only dreamed of. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.